Okay, today we're going to be doing the lesson on factoring. We're going to start off with simply pulling out a greatest common factor, also known as your GCF. Okay, so when we look at this is a binomial. There are two terms. We look to see what do they have in common that we can factor out. This would be a 3. When we pull out a 3, we're left with x squared plus 2. And we were done with that problem. For number 2, we have 12x squared plus 40. We have to think of 12 and 40. What is the greatest common factor that we can pull out of 12 and 40? Okay, that would be 4. And we're left with 3x squared plus 10. And since 3 and 10 have nothing in common, we cannot pull anything else out. This problem here, notice that our lead term here has a negative with it. And our degree of this polynomial is a 2. So when your lead term is a negative, you need to make sure that you factor out the negative. So my greatest common factor here would be negative 3. That takes care of the numbers. Now look at your variables. We have an x squared and an x. So we can pull out an x. When you pull out a negative, you have to be careful because your signs will be changing. So when we divide this by negative 3, we are left with x. Okay? And then when we divide the second term by negative 3, we are left with a 13. But be careful, notice this sign, a negative and a negative, now that is a positive. And you can always check yourself because you can distribute this back through to make sure that you are getting negative 3x squared minus 39x. The next set of factoring problems deals with a pattern. It's called a difference of two squares, otherwise known as dots, difference of two squares. So you need to be thinking and looking at and being able to recognize numbers such as 1 squared, which is 1, 2 squared, which is 4, 3 squared, which is 9, 4 squared, which is 16, 5 squared, which is 25, 6 squared, which is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81. You should be pretty comfortable. We call these numbers your perfect squares. So when we look at this, we have an x squared. That is considered a perfect square. 49 is a perfect square. We can multiply 7 times 7 to get 49, x times x to get x squared. So here we would consider our a value to be x, our b value to be 7, and then it falls into the pattern of x minus 7, x plus 7. You can check yourself by foiling this problem back out with your first terms, your outer, inner, and last. Notice the middle terms, when you combine like terms, cancel. Okay, number 5. Perfect square here, our a value would be 3x, our b value will be 8. 3x times 3x gives me 9x squared. 8 times 8 gives me 64. So then we follow into our pattern. It would be 3x minus 8, 3x plus 8. Some more practice with this. If you look at number 6, you need to be careful here. It looks like these are both perfect squares. So a would be x, b would be 2. But we have a plus sign here. So it is not a difference of two squares. What this would look like graphically would be a quadratic with our vertex at 0, 4. And if we were to graph this, you will notice the graph does not cross the x-axis. So we're not seeing the solutions, which means they're not real, which means this is not a factorable problem. If we look at 7, this one is two perfect squares. X squared is a perfect square, 1 is, and there's a subtraction. That means difference, so we can factor this. A here would be x, B would be 1. So the pattern would be x minus 1, x plus 1. The next set of factoring problems, we have already covered a GCF. We've covered a pattern, difference of two squares. The next set would be grouping. So if you were to look at this expression for number 8, and you notice that both parts here have an x plus 3, we can factor out the x plus 3 and look at what is left over. We have 2x plus 5. So x plus 3 was our greatest common factor here. If we look at number 9, both of these have a greatest common factor of 4x plus 5. So here when we look at these problems, our GCF is no longer a monomial, but it is a binomial. Once we factor out the 4x plus 5, we are left with 3x minus, okay, now that you've factored out the 4x plus 5, you got to think division here. 4x plus 5 divided by 4x plus 5 is 1. So you must fill the spot with a 1, not leave it blank. So now when we look at problems 10 and 11, notice we have 4 terms. When you see 4 terms, we call this factoring by grouping, because we're going to group the first 2 terms together and then the second 2 terms together. And then you look at for a GCF. So looking at our first 2, x squared plus 12x, what is our GCF here? We can pull out an x, and we're left with x plus 12. Looking at our second set, we have a negative 4x minus 48. Now remember, our lead number here is negative. That is a negative 4. So we need to, and you must pull out a negative. So I'm going to pull out a negative 4. When you pull out a negative, you need to be very careful. Remember that the signs will change. So negative 4x divided by negative 4 is an x. It's now positive. Negative 48 divided by negative 4, okay, that's going to give me a positive 12. If you have done this part correctly, what is left inside the parentheses should match. And now we can continue to pull out a GCF since they both have x plus 12. And what are we left with? We're left with an x minus 4. Number 11, notice we have 4 terms, so we're going to group the first 2 together and the second 2 together. The first 2, the greatest common factor is an x. So if we factor out an x out of x squared, we're left with x. If we factor out an x out of negative 7x, we're left with negative 7. The second set, notice the negative 2x. It is negative. So we're going to have to pull out a negative 2. Keep in mind, when you pull out that negative, the sign must change. So we have negative 2x divided by negative 2 is x. 14 divided by negative 2 is negative 7. If you did things correctly, what's left in the parentheses should match. So we're going to go ahead and pull out x minus 7 out of both terms, and we are left with x minus 2. The next 2, both 12 and 13, have 4 terms, so we're going to factor both the same way using the grouping method. So I'm going to group my first 2 terms and my second 2. This time around, I have 2c squared minus 6c. So my GCF is not only going to have a number, but also a variable. I can pull out 2c. And then I am left with c minus 3. Negative 1c plus 3. There isn't necessarily a greatest common factor that I can pull out, but be careful when this is the case and negative 1c, it's negative. Make sure you pull out a negative and pull out a negative 1. That is going to change the sign. So now we will be left with c minus 3. Notice what's left in the parentheses does match. So if I pull out c minus 3, and what's left over is 2c minus 1. Number 13. Once again, 4 terms, so I'm going to factor by grouping. 4n squared plus 10n, I can pull out a 2n. I'm going to be left with 2n plus 5. The second set, 6n plus 15. 6 and 15, I can pull out a 3. And then I'm left with 2n plus 5. What's in my parentheses is the same, so I'm going to factor that greatest common factor out. That's a 2n plus 5, and I'm left with 2n plus 3. So the final method that we have, we've gone over GCF, we've looked at the pattern difference of two squares, and we looked at grouping. This third method, the most common method that we do use, is when you have 3 terms. Okay, this is a trinomial that we are trying to factor. Let's remember these when we are factoring quadratics, that the standard form of a quadratic is ax squared plus bx plus c. I will be referencing a, b, and c. A is the coefficient to your x squared term. B is the coefficient to your x term. And c is the constant. So when we have a trinomial, we are going to have to come up with 2 numbers that we can multiply together to get a number, but also add together to get a number. So our step 1 is we take a and c and we multiply them together. So for this example, it would be 2 times 6, which would be 12. So we have to ask ourselves, what can we multiply to get 12 and add together to get 7? So a lot of times, we create ourselves a little chart. We know that we want numbers that we can multiply to get 12, add together to get 7. So we know that we can do 1 and 12, 2 and 6, 3 and 4. So we have 3 options here. There is only one option, though, that will allow us to add to get 7. So now that we have the 2 numbers, we know it needs to be a 3 and a 4. We are going to go back to our original equation, and we're going to rewrite the middle term, the 7x, using our 2 numbers. So we can rewrite 7x to be 3x plus 4x. If you notice, at this step, we have taken our trinomial and we have created, instead of 3 terms, we have 4 terms. And we now can group. So we're going to group the first 2 terms together. We're going to group the second 2 terms together. And then we're going to start looking for a GCF. So out of the first 2, 2x squared plus 3x, I'm going to pull out an x. And I'm left with 2x plus 3. The second set, 4x plus 6, I'm going to pull out a 2. When I do that, I am left with 2x plus 3. If you notice, what's left in the parentheses is the same. So if I factor out my greatest common factor, 2x plus 3, I am now left with x plus 2. And you have factored a trinomial with the lead coefficient not being 1. So we're going to practice this method. So here we have, for 14, we have a trinomial. So we need to figure out what a times c is. And that would be 3 times 8. So that's 24. So we're going to be looking for numbers that we can multiply together to get 24. And we want b, which is negative 10. So we start listing out our factors that would multiply together to get 24. It's 1 and 24, 2 and 12, 3 and 8, 4 and 6. I know to stop there because then I start repeating myself and it would be 6, 4. So when you look at this, I see two options where I could possibly get 10. So you kind of have to ask yourself, I need to get negative 10, but I need to multiply these two numbers to get a positive 24. So my two numbers have to have the same sign in order for them to be multiplied together to get a positive 24. 2 and 12 would give me a negative 10, but I would have to have a negative 12, positive 2, and that's not going to be able to multiply together to give me a positive 24. So 4 and 6, I could do negative 4 and negative 6. They will give me a negative 10, and when I multiply them, I would get a positive 24. That is step 1. Step 2 is to take your middle term and replace it with the two numbers we found. So we have 3x squared minus 4x minus 6x plus 8. Notice I've kept the first term and the last term the same. I'm just replacing the middle term. Now we are going to group. And I look at my first two, I have 3x squared minus 4x. The only thing I can pull out is an x. I look at my next two terms, I have a negative 6x plus 8. Once again, be careful, that is a negative 6. So I must pull out a negative. 6 and 8, my greatest common factor would be 2. So I'm going to pull out a negative 2. And remember to be careful. When you pull out a negative, the sign will be changing. So negative 6x divided by negative 2 gives me a positive 3x. 8 divided by a negative 2 gives me a negative 4. Once you look at what you have, what's left in the parentheses should be the same. It is, and we can factor it out, and we get 3x minus 4. Then we look at what we have left over, and our second binomial here will be x minus 2. Number 15, we have a trinomial again. We do not have any GCF that I can factor out, so we're going to start right with what is a times c, and what's our b? Well, a times c is 1 times 20. So I want some numbers we can multiply to get 20, but I need a negative 9. So that's 1 and 20, 2 and 10, 3 doesn't go in there, 4 and 5, and then I will start repeating. There's only one combination here that will give me the negative 9, and that's the 4 and 5. They both need to be negative, so when I add them together, I get a negative 9. That's step 1. Step 2 now has us go to the rewrite, where we're going to rewrite our middle term. So we're going to have x squared minus 4x minus 5x plus 20. We are now going to group the first two. group the second 2. I have x squared minus 4x. I can factor out an x, and I'm left with x minus 4. Once again, I keep repeating myself. If this term is negative here, see how we have negative 5x, negative 5x. We need to pull out a negative here. So we're going to pull out a negative 5. When we do that, careful with the sign changes. Be very careful with your signs. This is now going to be a positive x, and a 20 divided by a negative 5 is going to be a negative 4. If you have done so correctly, what's left in your parentheses will be the same, and we're going to factor out the x minus 4. And then we look to see what's left, and we have x minus 5. So, to factor completely, you need to be careful. Sometimes there are more than just 2 steps to factoring. You always need to check, no matter if you're factoring a binomial, trinomial, that you do not have a greatest common factor that you can pull out first. So when you're looking to factor, sometimes the very first step should always be look for a GCF. Okay, if you have 2 terms, you need to look for the pattern. Okay, if you have 3 terms, you're going to do the A times C method. If you have 4 terms, you're going to be looking to group. Looking for the GCF is always the first step. So for example, number 16, it is a trinomial. But when I look at this problem, I see that I can factor out a 2 out of all 3 terms. The GCF has to be pulled out of every single term. So I factor out a 2, and I'm left with x squared plus 6x plus 8. Notice I could not factor out an x because all 3 terms did not have an x. That's step 1. That was my GCF. I still have a trinomial, x squared plus 6x plus 8, that I now need to factor. I'm going to use my a times c and my b. A times c is 1 times 8. My b here is 6. So I have to think of numbers that I can multiply together to get 8. It's 1 and 8, 2 and 4. That is it. I have to look to see which one will give me 6. That is 2 and 4. Both of them would need to be positive. So the next step that I have is I'm going to replace this 6x. So I'm going to go ahead and carry this 2 down because it's already been factored out. So it will be part of my final answer. But it does not take place when I'm factoring this trinomial. So I have x squared plus 2x plus 4x plus 8. I'm going to group my first 2 terms and my second 2. I'm going to go ahead and bring this 2 down again, but then I'm going to look at my GCF for my first 2 terms, x squared plus 2x. So I'm going to factor out an x, and I'm left with x plus 2. Looking at my second 2 terms, I have 4x plus 8. I'm going to factor out a positive 4, and I'm left with x plus 2. Notice x plus 2 is common, so I can pull that out, and I'm going to be left with x plus 4. I'm going to go ahead and carry down my 2, pull out my x plus 2, and I'll be left with x plus 4. So that 2 is part of the full factored form for this expression. Number 17, we're looking for a greatest common factor here. Notice my x squared term is negative, so we're going to pull out a negative. I can pull out a negative 2. I cannot pull out an x or a y because they are not common in both. So if I pulled out a negative 2, Be careful when you pull out a negative, your signs will be changing. I'm going to be left with a 9x squared. If I pull out a negative 2 out of a positive 8y squared, I'm going to be left with a negative 4y squared. So this problem started off with a GCF. I am left with only 2 terms. So I need to ask myself, does this hit a pattern? The only pattern we have so far is dots, difference of 2 squares. This is a difference of 2 squares. 9x squared is a perfect square. Negative 4y squared is a perfect square. So when we go to factor this, our a would be 3x, our b would be 2y. And then we can put it into the pattern, which once again, remember our pattern was a minus b, a plus b. Notice in the beginning of this problem, I pulled out a negative 2. That is part of the factored form. So I'm going to pull it, go ahead and write it in front. And then I will finish with my pattern, 3x plus 2y, 3x minus 2y. And that is your final factored form for this equation. Sorry, it's not an equation, it's an expression. Notice this expression started off with 2 terms, and I had to pull out a GCF. Make sure the lead term with the x squared was negative, so I pulled out a negative. And then I was left with 2 terms, but they hit a pattern. So be careful to look for a pattern in GCF.